Good morning. My name's John Capadonna, and I'd like to. Good morning. My name is John Capadonna, and I'd like to present this slide program entitled Integrated Pest Management, a gardening philosophy for home gardeners. Integrated Pest Management, or IPM, at its core, IPM is an environmentally sensitive yet common sense approach to pest management. Some of you may be skeptical because I used environmentally sensitive and common sense in the same sentence. The two are not mutually exclusive, though. IPM is not an organic program, it's a proactive approach to management of pests, including insects and weeds. A pesticide is any substance used to control pests. The IPM philosophy of managing pests is to use the pest management solution that is the least damaging to the environment. It's a proactive approach that can be viewed as a pyramid. The most broad proactive solutions form the base or the foundation of the pyramid. As you make your way toward the apex, the solutions become more specific and have the most negative effects on the environment. They are the last resorts in solving a pest problem. Therein lies the philosophy of IPM. It is using the solution that is the least damaging to the environment, beginning with proactive, broad approach and ending with a chemical solution only as a last resort. I'm a baby boomer and I was born in the early 50s. After World War II, companies that had been busy making wartime products had to gear up to produce peacetime products. It was a prosperous time, and convenience was at the forefront of consumer products. Things that made life easier, especially for busy moms, were popular. Think TV dinners, processed foods, and home and garden insecticides. I think my family was fairly typical. My mom was a stay at home mom, and her home was a top priority. Insects were not tolerated, and if an insect showed itself in the house, out came the household insecticide spray, and she sprayed the baseboards all over the house. Heaven forbid a roach showed itself, then the exterminator was called and the house was sprayed inside and out. I recall a TV slogan that was better living through chemistry. Chemical solutions to pest problems were the default solution. Chemical solutions were not only the default for moms, it was the default for state and city agencies tasked with public health problems. DDT, a chemical insecticide, was used to control mosquitoes, which are vectors for some of the world's deadliest diseases. It worked so well that by the end of 1945, it was available to the public in the U.S. It was promoted by the government and industry as an agricultural and household pesticide. It worked so well that it was used indiscriminately. In 1962, Rachel Carson's controversial book, Silent Spring, was published, and it talked about the environmental impacts that correlated with the use of DDT, particularly birds of prey. There was a firestorm of controversy between environmentalists, government agencies, and corporations over the use of DDT. In science, correlation does not necessarily mean causation. It requires proof. The correlation between DDT and the decline in bird populations was difficult to prove because it was not fatal to the adult birds. It took researchers a while to understand that DDT caused the thinning of eggshells to the point that they could not support the weight of the adults during incubation. Of course, this resulted in reproductive failure, and when the older birds died, they were not replaced, and so the populations collapsed. It took 10 years, but public outcry led to the ban on DDT and for most uses in the U.S. This controversy fueled the environmental movement that led to many reforms. The acrimonious debate during this time led to much distrust and animosity that still persists. This is what led to my comment about skepticism, where common sense and environmental sensibility are concerned. Scientific data has borne out the facts, and concern for the environment is much more mainstream these days. Those 70s environmental activists are now 75-year-old boomers. One of the best things to come out of the environmental movement was that concern for the environment became much more mainstream worldwide. Awareness that things we eat, drink, and breathe affect our health. Organic gardening was born. The beauty of IPM is the freedom to practice organic gardening or not. It's inclusive rather than exclusive. IPM is not an organic gardening method. It's an environmentally conscious method of gardening. For some of us, it may require a shift in mindset. It means accepting that reaching for a pesticide, organic or chemical, should not be the first choice. It should be the last resort. So let's explore how to make IPM systems work for you. We begin at the base with cultural and sanitation solutions. This is a very broad category that includes plant selection in the landscape and in your garden, building diversity, and improving soil in the garden, and how you manage sanitation in the garden and in your landscape. In the landscape, we want to select trees that are native to Texas and your area if possible. Various oaks are popular, but things like desert willow and even mesquite work well and are much more water-wise. Look for native shrubs like yaupon, flame acanthus, Turk's cap, American beautyberry, and esperanza that provide fruit or flowers that are attractive to hummingbirds and pollinators. Blue mistflower is a butterfly magnet that provides nectar for migrating and resident butterflies alike. There are dozens and dozens of choices of native perennial flowers, shrubs, and trees. Let's talk turf. I'm the poster boy for what not to do with turf. If you have an existing yard with Bermuda grass, no one expects you to tear it out. Turf is very unpopular these days because it consumes so much water. Out here in West Texas where I live, water is a very valuable resource, so the less water you expend on turf, the better. On the other hand, some turf is acceptable and even beneficial, and there are some good native grasses like buffalo grass, blue grama, and curly mesquite that when blended together make a very attractive native turf. It requires much less water and requires less mowing too. If you're moving into a new home with no yard or have a small yard, you may consider replacing your turf with native grasses. When thinking of the landscape, think native plant diversity. Learn to think of your property as an ecosystem that you're responsible for. An ecosystem is a biological community of interacting organisms and their physical environment. all the plants, animals, insects, and even microorganisms on your property make up your ecosystem. Think of a healthy, functioning ecosystem like a large, complex machine with many parts. Some of those parts are redundant and perform the same function. When all the parts are in tip top shape and functioning properly, the machine runs smoothly and efficiently. If one part breaks, the machine may continue to run, but the more parts that break or go missing, the less well the machine runs. And if enough parts fail, the machine stops altogether. That's the way an ecosystem works. The idea is to build a healthy native ecosystem that is on your property. So far, everything we've discussed is part of cultural controls. It involves selecting native plants, trees, and turf. So next, let's look at sanitation. Sanitation in the landscape will be different than in your vegetable garden. In the fall and spring, leaves will drop from the trees and leave them on the ground where they fall until summer. When I mow, I leave the grass clippings on the lawn. The leaves that are on the lawn get ground up with the grass clippings and are returned to the turf where they will eventually decompose and feed the soil. The leaves that fall in the beds remain there to serve as mulch. The fallen leaves provide habitat for insects and pollinators that overwinter there. The leaves that do not get raked up go into a large bin and are used to make compost or mulch for the vegetable garden aisles. None of the grass clippings or the leaves ever leave the property. They are all returned to the soil ecosystem. Sanitation in the vegetable garden is a completely different matter. Keep your vegetable garden beds clear of dead or dying plant debris. Debris in your garden gives unwanted insects a place to hide or winter over. You don't want to provide a good wintering habitat for squash bugs in your garden beds. It also gives you a clear view, and we'll talk more about that in the physical and mechanical portion of the presentation. Plant selection in the vegetable garden is an important part of as much as it is in the landscape. Look for varieties that are disease resistant. Look for varieties that do well in your area. Timing is very important. Plant the right thing at the right time in good soil, and your plants will be healthy and robust, and they will resist pests much better than sickly plants. Rotate crops. Don't plant plants in the same family, in the same place, season after season. Not only do they use the same nutrients, but they're often vulnerable to the same diseases. For example, tomatoes, peppers, eggplants are all part of the Solanaceae family or nightshade family. Don't plant peppers immediately after tomatoes or eggplants. I use a 3-year rotation in my garden. It's harder to do in a small garden, but perhaps it may be best to just skip certain plants from time to time to assist in rotation. The photo shows the native soil in my yard on the left and my garden soil on the right. When planting native trees, plants, and turf in the landscape, native soil works because the native plants evolved in native soil. So amendments are not necessary. The native soil benefits from fallen leaves and other organic materials that make their way into the soil naturally. Native grasses do not require fertilizer. But if you have Bermuda or one of the other popular turf grasses, they do benefit from some fertilizer when actively growing. I like to use an organic fertilizer, but the most important thing is to avoid fertilizers that contain pesticides, such as a weed and feed fertilizer. It's very easy to be fooled by the convenience of products like that. But indiscriminately spreading herbicide over your yard might easily damage trees and shrubs. A few weeds in the lawn just adds a little diversity. The same is not true for your vegetable garden. The vegetables we grow in our gardens come from all over the world. One thing they have in common is that they thrive in fertile soil. As you can see, my native West Texas soil is nearly devoid of organic matter, and it's very sandy. The garden soil on the right is rich in organic matter. And while native soil is fine for the landscape, vegetable gardens require fertile soil. Forgive me for going down this soil science rabbit hole, but soil is probably the single most important cultural control in the vegetable garden. Good fertile soil is rich in organic matter. It has good soil structure. It's friable. It holds moisture well, but it allows excess water to drain away. That same soil structure also holds air. Most importantly, fertile soil is teeming with life. According to Dr. Kate Scow of UC Davis, a gram of soil, about a quarter of a teaspoon, can easily contain 1 billion bacterial cells and several miles of fungi filaments, or hyphae. In nature, plants grow in the topsoil. They mature, die, or they're consumed and return to the soil where the billions of bacteria, archaea, and fungi consume the organic material and are in turn consumed by the protists, arthropods, and nematodes. These organisms are each consumed by a higher trophic level and add their waste and dead bodies to the soil. This is known as the soil food web, and it supports all terrestrial life on Earth. It is the bodies of the billions of bacteria, archaea, and fungi, the bodies and waste of the upper trophic levels of organisms that provide the nutrients that plants require to grow and thrive. There are about 18 nutrients that plants need, and all but carbon dioxide come from the soil. Good soil equals healthy plants. Good soil results in healthy, robust plants, and healthy plants resist disease, insects, and weeds much better than sickly ones. I dare say in a home garden, soil is the most important cultural control in the IPM program and does more to eliminate pest problems than any other single thing you can do. So how do you get great soil? The simple answer is compost, compost, compost. If you're gardening in a conventional row garden in native soil, it's virtually impossible to get too much compost. It doesn't matter if you have sandy soil, like our West Texas soil, or clay soil. Compost improves both the soil structure and fertility. In the garden, especially if you're following sanitation protocols, compost supports the soil food web by replacing the organic material that we remove. If you're gardening in raised beds and you start out with fertile soil that contains lots of compost, it is possible to overdo it. Yes, I'm the poster child for gardening mistakes. After 8 years of adding compost to my already rich raised bed soil twice a year, I noticed a slight decline. I decided to have my soil tested, and this is the report I got back. It was a little short of NO3 or nitrogen and long on phosphorus. The nitrogen is an easy fix. Just use a little blood meal every 4 to 6 weeks. But I was puzzled with how the phosphorus got so high. And one of the great perks about being a master gardener is having access to experts. So I asked Dr. Joseph Burke, who happens to be a soil scientist, what could cause the phosphorus to be so high. Turns out compost is very high in phosphorus, and it's more persistent in the soil than some nutrients like nitrogen, which get used up and move vertically through the soil faster. I followed the advice from the soil test and just used a little nitrogen on my plants, and they are back to their robust, healthy selves. So now I'm a vocal advocate of soil testing. Test, don't guess. We talked about planting native plants in the landscape to produce diversity. Now let's look at flowers in the vegetable garden. It seems like companion planting is all the rage these days. I'm not sold, so I tried to find information in legitimate sources like university extensions. The answer was yes, no, maybe. There's some scientific evidence that, like French marigolds, repel nematodes. Turns out it only works when you turn the plants into the soil. There are a few others that may be beneficial too, but it all depends on the semantics of what you call companion planting. To most people, it means planting companions right next to each other in the same bed or row. And I don't buy that at all. A marigold in my tomato bed is just a weed. A plant in a place I don't want it. I don't go through the trouble to blend good soil and keep it fertile only to place competing plants among my vegetables. Another issue is that for some reason I'm forced to use an organic or chemical pesticide. Companion planting would make it impossible without a lot of collateral damage. Remember, the point of IPM is to use the least damaging solutions. I'm a firm believer of flowers as an integral part of a vegetable garden that may seem contradictory to what I said on the previous slide. Now, let me explain. I'm convinced that having flowers, especially native ones, is a big benefit to the vegetable garden. The flowers provided needed diversity. They attract native pollinators, and perhaps most important, they provide essential habitat for beneficial insects. The difference is that I don't plant them in the same bed with the vegetables. I provide a dedicated space for them in close proximity to the vegetable garden. In this way, they do not compete. They are not weeds. If I'm forced to use an insecticide for any reason, it doesn't kill my beneficials that are at home in the flowers. Remember, IPM is an ecologically friendly and common sense approach. Herbs are a favorite part of my vegetable garden. In addition to having fresh herbs year round, they attract tiny native pollinators, tiny bees and flies. Yes, flies are pollinators and are attracted to the tiny blooms that many herbs like parsley, fennel, dill, celery, and cilantro make. In addition, some herbs are butterfly host plants. Parsley, dill, and fennel host the black swallowtail. The caterpillar is as beautiful as the butterfly. Plant enough for both of you and the caterpillars because they can eat a lot. Hosting butterflies adds diversity. Forgive me, I know this section seems to be going on forever, but cultural controls and sanitation, along with the next level physical and mechanical controls, are the proactive parts of IPM. They form the foundation of a good IPM program, so please bear with me a little longer. I have a friend, Susan, who is an evolutionary biologist with a PhD who spent her professional career working in forestry and agriculture. Sometimes I'll lean on her for information. A piece of advice she gave me that I think that's worth sharing is that she advised me to not leave soil with nothing growing in it. If you don't garden year round like I do, then plant a cover crop. In the past few decades, the importance of symbiotic relationships between mycorrhizal fungi has been in the forefront, and plants produce sugars through the process of photosynthesis, and they are distributed to the plant dissolved in water through the phloem vascular system, all the way to the roots. The roots excrete some of these exudates, and they attract the mycorrhizal fungi to the area around the roots. What makes these fungi so unique is that they penetrate the roots to take up the sugary exudates, and in return, they bring water and nutrients to the plant through their hyphae. This increases the plant's ability to take up water in nutrients many-fold. It's important to have plants in the soil to feed those fungi. It's also best not to till deeply so that the mycorrhizal hyphae are not disturbed. One last tip: if you garden in the fall and winter like I do, I leave my brassicas in the ground and they continue to feed the fungi. But in February, when it begins to warm, they bolt and produce an explosion of blooms. Bees are out foraging in the warm weather, and these blossoms provide important forage because there's not much blooming at that time of the year. It's a win for the fungi, it's a win for the bees, and a win for you. Last but not least, I'd like to discuss irrigation. In West Texas, where I live, irrigation is essential both in the landscape and in the vegetable garden. Drip irrigation is the best, most effective option. Unless you have installed your landscaping recently, you probably have sprinklers. And while drip is best, there are now replacement nozzles for pop-up sprinklers that are 30% more efficient. They are inexpensive and easy to change and well worth the effort it takes you to change them if you have sprinklers in your lawn. All my raised beds are equipped with drip irrigation. I'm using 12 millimeter drip line with 0.26 gallon per hour pressure compensating self-flushing emitters that are on 6-inch spacings. Depending on the bed, I have from 4 to 6 drip lines. With 6-inch spacing, this gives me a very even distribution. This line is stiff, so I have to provide them with a removable connection so that I can lift the entire grid out of the bed for prep work. I have repurposed an existing underground sprinkler system with a programmable controller, and this enables me to control the water very precisely. Drip irrigation is by far the best option for a vegetable garden. Having it on a programmable timer is a big plus. There are battery-operated timers that are attached to a hose bib and can control up to 3 zones. The downside is that they'll freeze in the wintertime, so if you have to be very careful. More sophisticated systems of timers and valves like those used in landscape work very well and are available to handle up to as many as 12 zones. Well, that about covers control and sanitation. So now we move on to physical and mechanical solutions. I think raised beds are a great place to begin exploring physical and mechanical solutions. Most of the vegetable gardeners I know are urban or suburban gardeners, but even if you live in the countryside, raised beds may offer the best solution to some very common problems. They provide a structure to hold the soil. You have the opportunity right from the beginning to blend great soil. You can standardize your beds like this 4 by 8 foot bed or build them to fit any space you like. Every part of this bed has a purpose. It's 18 inches high, which is a comfortable height to sit. I'm 73, and ease of maintenance is very important to me. I think that ease will enable me to continue gardening as long as possible. Raised beds make it easy to attach sockets for hoops or install a trellis or other accessory. They're comfortable working height, which is important when using physical solutions to remove insects, planting, or weeding. Taller beds make weeding a breeze because weed seeds don't blow in easily. Most weeds are delivered by birds, and so there's not too many. Raised beds are easy to install drip irrigation, and they're easy to hand water when required. It's easy to apply fertilizers and compost. You might see I'm sold on raised beds as a great physical and mechanical solution to many problems. Stakes and cages are two uh, physical and mechanical solutions that I consider indispensable. There may be some crossover to cultural solutions, but they're still proactive solutions. I'm something of a fanatic when it comes to staking plants. It seems like such a simple and obvious solution to me. I stake tomatoes as I transplant the seedlings. The truth is, I stake them in the greenhouse. The minute they go in the ground, they get staked. West Texas is notorious for strong spring winds. 50 or 60 miles an hour are not uncommon. Staking can simply save your plants. I use orchid clips to secure them to the bamboo stakes because they are easy to move as the plant grows. I remove lower limbs so that none touch the ground or they're close enough that water may splash from the soil to a leaf. Pathogenic fungi spores are in the soil everywhere, and if they land on a leaf in a water droplet, they will germinate. This is how tomatoes get blight. The simple measure is the best blight prevention I know of. Staking summer squash is one of the best ways to combat squash bugs. Summer squash are not the easiest plants to stake. Start early and get the stake close to the plant when it's small. I use plastic tie tape. It has some give and yet it's sturdy. As the plant grows, remove lower branches and try to keep the ground surrounding the plant clear of debris. I go out in the morning and scoot along on my garden scooter and check the plants for adult squash bugs. If I find any, I dispatch them. Some people like to use a small portable vacuum for this. And yes, that's another mechanical solution. For me, I just wear gloves. I also check the underside of the leaves for eggs and remove any that I find. And at the same time, I hand pollinate any receptive female blooms. This may seem tedious, but it's really not bad. You can do this for 8 or 10 plants in about 20 minutes. If you're diligent about this, you should not have any eggs hatch, and I have found this to be more effective than any insecticide I've ever used. Tomato cages work well for tall plants, like tomatoes and peppers. They work well especially for tomatoes because they eliminate the need for pruning to train them to a stake. or a trestle. In the photos, I have determinate tomatoes on the left and indeterminate tomatoes on the right. I use 2 cages for tall indeterminates. I invert one on top and attach them together with hog rings. Note that both have plenty of space underneath to provide ventilation and prevent water from splashing on them from the soil. Row cover was designed to provide frost protection. It comes in different weights that provide between 4 and 8 degrees of protection. The lighter row covers let in more light, and the heavier covers less. The light transmission ranges from about 85% on the light end and 50% for the heavier materials. Row covers made from a non-woven polypropylene fabric. The lighter weights are often referred to as floating row covers and can be supported by the plants themselves, where the heavier fabrics require some sort of support, such as hoops. I use inexpensive metal binder clips to secure the row cover to the hoops on my beds. This photo was taken immediately after a 60-mile-an-hour spring windstorm last spring. As you can see, it survived undamaged. How you secure the row cover is key to its success in windy areas. I found that quality row cover performs exactly as advertised, providing the stated protection. Row cover can protect against a light frost in the spring or fall, which reduces stress, resulting in healthier plants. The interesting thing is that row cover also provides a very effective physical barrier to insects. It can keep out very small insects such as thrips and whiteflies. With some proactive use of BT or diligent hand removal of caterpillars, it's possible to grow flawless greens like collards in the fall. Here in West Texas, I consider it indispensable for growing tomatoes. Shade cloth is intended to block a certain portion of the sun's radiant energy. And unlike row cover, it's rated by the amount of light it blocks rather than the light that is transmitted. I find 30, 40, and 50% are the most useful for West Texas. Shade cloth can significantly reduce the heat and water stress and prevent scalding of fruits like tomatoes and peppers. It can reduce soil temperature on a 100-degree day by as much as 10 degrees and surface temperatures by as much as 65 degrees. This can significantly reduce stress from heat, excess transpiration, and it helps conserve water both in the soil and in the plants themselves. I can't resist showing you this slide. Being the nerd that I am, I like to test claims about shade cloth or anything else. What you see here is an infrared thermometer that reads the surface temperature of objects. On a hot summer day, when the ambient temperature was right at 100 degrees, I went out in the garden and I took these temperature readings. The one on the left is the soil surface under 50% shade cloth, and the one on the right is the soil surface in the sun just a few feet away. The one on the top is showing a difference of 65 degrees, and the one on the bottom is showing a difference of 71 degrees. I think that's just incredible. Just imagine what a difference that makes to a plant's leaf surface. This stuff works. Shade cloth also provides a barrier for insects such as cabbage white butterflies and the cabbage looper moth. It also works to exclude sphinx moths from tomatoes, preventing tomato hornworms. It's the best bird netting I've come across. At the same time, It shades my tomatoes in the spring and summer, and it also keeps the birds and squirrels from ruining my tomatoes. It also protects my greens in the fall. Spinach and lettuce wouldn't stand a chance against the birds without it. Here in West Texas, seasonal changes often bring violent weather, and one of the most disappointing things is to lose a garden to a spring hailstorm. Installed on hoops as shown, this shade cloth provides a very effective shield against small hail that would otherwise destroy a garden. When I build a raised bed, I install sockets for hoops. Hoops support row cover and shade cloth. The sockets are made from 3/4 inch CPVC and the hoops are 1/2 inch CPVC. I used CPVC because it's the only pipe that 1/2 inch telescopes snugly through 3/4. That keeps the hoops vertical and it easily supports any weight of row cover or shade cloth. Another nice thing about CPVC is it seems to be more resistant to the ultraviolet rays from the sun, and so it lasts indefinitely. I've been using these hoops for 8 years, and they don't show any signs of any degradation from the UV radiation. The hoops are simply 10-foot long, 1/2 inch CPVC pipe. There's no cutting to length required for a 3 or 4-foot wide bed. The photo here is a 4-foot wide bed, and the hoop makes a nice rounded support. It takes perhaps 5 minutes to install the 5 hoops on a 12-foot bed. I buy row cover in 10-foot wide rolls, and so the only cutting is required is to cut it to length. I have my shade cloth custom cut, and it lasts for years and years. The row cover lasts for several seasons. At first thought, removing insects one at a time by hand may sound unreasonable or even foolish. At least it did to me, but not everything in gardening is intuitive. My insect nemesis was squash bugs. It seemed impossible to get through a season without being overrun by squash bugs. I tried insecticides, but once they began to hatch out, it seemed impossible to get them all. Out of desperation, decided to try something that I'd read about. I staked my tomato plants using sturdy stakes, and I used shade cloth over the plants in my raised bed. We probably had 8 plants, which, if producing well, is way more squash than my wife and I can eat. The plan was to tie the plants to the stake, and as it grew, we removed the squash. We also removed lower or dying branches. The idea is to remove any debris that the adult squash bugs could hide under, and the shade cloth prevented them from flying in. Of course, that also precludes bees pollinating our squash, but I'll address that in a moment. I made it a point to go out each morning after the flowers had opened and any female blossoms were receptive and hand pollinate. I used my garden scooter to do this comfortably. The height of the raised bed and having the plants staked puts the plants right at my fingertips. At the same time I look for receptive blossoms, I search for squash bugs. I also examine the underside of every leaf for eggs. Now this sounds incredibly tedious, but it was not unpleasant at all. It was a great opportunity to observe the goings on in the garden. It only takes about 2 or 3 minutes per plant, so perhaps 20 minutes for 8 plants. To make this even more foolproof, my wife came out an hour or two after me to harvest, and she would follow the same procedure I did. Occasionally, she would find some eggs I missed or an adult that eluded me. The eggs take about 7 days to hatch, depending on the temperature, so between the two of us, it's very unlikely that we missed any eggs. Some some people use a small handheld vacuum to suck up squash bugs and other insect pests. And I can see where that would be a big help in sprawling vines or in capturing instars before they scurry off into hiding. I was surprised at how well this worked. When you were diligent in disposing of the eggs, you cause reproductive failure. And after a few seasons, you have significantly reduced the number of adults. This will work with other pests as well. It is definitely possible to remove tomato hornworms by hand. Searching at night with a black light makes finding them easier. And don't forget that the shade cloth is an effective barrier too. Weeds can be a nightmare or not so much. I don't have much of a weed problem in my raised beds because the height keeps out the majority of weeds. Here, most weeds are blown along the ground, and the lower the bed, the easier it is for the weed seeds to blow into the bed. The few weed seeds that germinate in my raised beds can easily be plucked out by hand or made short work of with my favorite weeder. This Cape Cod style weeder works great. Small weeds get uprooted when I cultivate the top few inches when I prep beds for planting. In West Texas, Palmer's amaranth or careless weed is a big problem. And each plant can make hundreds of thousands of seeds, and they lie dormant until they get water. Tilling brings more weed seeds to the germination zone, and so they can be overwhelming if you're gardening in a conventional row garden. Plastic or woven plastic mulches offer a workable physical alternative. Mulches do double duty in conserving moisture and deterring weeds. Wood and bark mulches are popular in the landscape, but I don't use wood mulches in my vegetable garden because wood mulch takes a very, very long time to decompose, which is a plus in the landscape, but not in the vegetable garden. If wood is mixed in the soil, it consumes nitrogen during decomposition. So as long as it lies on the surface, little harm results. But if you mix it into the root zone, then it's counterproductive. In my landscape, I use the fallen leaves from my trees as mulch, and it provides the same benefits, plus it helps overwintering insects. In the vegetable garden, I use mulch made from composted leaves. I spread it on the surface, and they slowly decompose over the course of the season. And when it comes time to prep for a new planting, they can just be worked into the surface of the soil with a cultivator. That avoids disturbing the mycorrhizal hyphae down below, but still works the compost in. If you don't make your own compost, I found that composted cotton burrs make a very good mulch that can be worked into the soil at the end of the season. Sticky traps are also a physical and mechanical solution, but they have a downside in that they catch whatever flies into them. In other words, they're indiscriminate. They're completely non-specific and catch the good with the bad. For that reason, they're best used in enclosed spaces such under row cover or under shade cloth or in a hoop house or greenhouse. One of the good things about them is that they are a great way of keeping track of flying insects in enclosed spaces. For obvious reasons, they don't work well for caterpillars. There are some sticky traps that contain pheromones that are not specific to that are specific to certain insects. Then that helps them become a little more target specific. Using trap crops to attract pests away from the main crop and then dispatching them is a physical and mechanical control, but it usually requires the use of an insecticide. For example, blue Hubbard squash is a popular trap crop to lure squash bugs, squash vine borers, and cucumber beetles away from summer squash and other cucurbits. You'll need to plant the Hubbard squash 2 or 3 weeks ahead of the main crop, and then the trap crop needs to be reasonably close so that it attracts the target species, but not so close that they easily jump to the main crop. You can just lure the insects to the Hubbard squash and hope for the best, but in most cases, it works best if they're then sprayed with a potent insecticide to kill them all out. For small insects and mites, washing them off with a spray of water works wonders. Tiny insects like aphids, when displaced from the underside of a leaf, can have a hard time getting reestablished. This is especially true if you spray several times. If you live in a place where it rains once a week, you may not ever need to do this, but out here in West Texas, where we get rain so seldom, it makes sense to wash your plants occasionally if you have a problem with aphids, or it works well with spider mites too. If they're not too bad, a couple of times may be all you need, but at times you may need to do it every day for a week. The best tool I've found is a hose-in sprayer with a mist setting or a mist nozzle. The mist is strong enough to wash away the tiny bugs and mites, but does not damage the plant when used at close range. But be prepared to get wet. You don't want to do this as you're leaving for work. I turn the leaves over with one hand and wash them away with the other. And yeah, I get pretty wet, but on a summer morning, it's not the end of the world. One last thing before moving on to biological solutions and controls. Plants in the last stages of their life cycle often decline in health. And at that stage, they often become infested with aphids. Don't be afraid to remove those plants from the garden entirely. Occasionally, aphids can infest just a branch or two of a single plant, and the best course of action may be just to remove that branch and dispose of it. So don't be afraid to remove a plant or a part of a plant if the infestation is really bad. Okay, so now we're to biological solutions and controls. The most common biological control that comes to mind is releasing predatory insects like lady beetles and green lacewings to control aphids and other soft-bodied insects. There are many other biological solutions, but it's important to identify the target so the proper selection can be made. Some biologicals are parasitic, some are nematodes, some are fungi and bacteria. A biological that I use frequently in the greenhouse is a strain of Streptomyces liticus bacteria. It's effective in helping to prevent dapping off, which is caused by various fungi. It can also be used to control powdery and downy mildew. When releasing insects like lady beetles, once the target species is under control, they're going to leave. They have to in order to survive. Planting native plants around the garden to provide habitat will help hold them and build a resident population that can expand and contract to keep pests under control. Some predatory insects, like assassin bugs and mantids, are generalist predators and they'll happily eat the beneficials right along with the pests. You wouldn't want you would want to be mindful of that fact if you're releasing them in your garden. Still, they add to the diversity of the garden and landscape ecosystem and are beneficial. As far as I know, there are no biological controls for weeds or noxious plants that are available to the public. There are some reserved for governmental agencies. One that comes to mind is the tamarisk leaf beetle was introduced along some Texas rivers to control tamarisk or salt cedar. I don't know how successful it's been, but these kind of solutions are not really available to a home gardener, so we'll move on. We've arrived at the point where my version of IPM differs slightly with conventional programs. The difference is only in presentation, not in content. IPM is not an organic program. It includes chemical pesticide solutions as well as organic ones. The fact that it's inclusive is one of the things that I like best about IPM. I think it appeals to people like me that wish to be as environmentally conscious as possible but don't want to rule out the use of a chemical solution if the situation warrants it. I've inserted a level on the IPM pyramid that is organic pesticide solutions because to me it makes sense to have a chemical pesticide solution as a very last resort. Have an organic pesticide solution level also gives those that wish to practice organic gardening or have need to maintain a USDA or ORMI certification a clear demarcation. A pesticide is any substance intended to prevent, destroy, or control any pest, including a disease or unwanted species of plants or animals that cause harm or otherwise interfere with production or storage of agricultural commodities and ornamental crops. That means that products that and seemingly innocuous as soaps are considered pesticides. Organic pesticides are typically not as persistent in the environment. They degrade or decompose quickly, so their effectiveness is short lived. There are many regulations concerning pesticides, and for good reason. They're powerful substances that can be potentially harmful to the environment and to organisms, including plants, animals, and humans. Always read and follow the instructions on the label, not only to ensure its safety and effectiveness, but it's the law. Unlike many other labels, pesticide labels are legally enforceable. I find labels on products hard to read because the print is so small. But most product labels are available on the internet and are much easier to read. And you can check out to see the active ingredients, what the active ingredients are in any listing such as USDA or ORMI, which is a very important thing to see if the product is listed for a target pest. But you can do all that in advance without buying the product. So up until this point, most of the IPM products and solutions have controls and solutions rather are proactive. Some pesticides are used proactively, but more often than not, they're used when a problem arises. Most pesticides, and particularly insecticides tell you they work best if you catch the problem early before an infestation becomes acute. So let's begin with insecticidal soaps and oils and work our way up to broad spectrum insecticides. Commercial insecticidal soaps are potassium salts of fatty acids. Soaps disrupt the cell membranes and the cell contents leak out quickly, killing the insect. To be effective, soaps must make direct contact with the target insect. There's no residual effect once the soaps have dried, and they quickly wash off and degrade, so they're not persistent in the environment. Soaps have very low toxicity to mammals, making them safe to use around pets. Soaps are most effective against soft-bodied insects like aphids and spider mites. It has little, if any, effect on beetles and insect eggs. As with any pesticide, read and follow the instructions. There are hundreds of home remedies, but I avoid them simply because there's no data on them and no specific instruction on mixing or use. As with any insecticide, only use it on the listed insects. Some plants, such as lantana, are sensitive to soaps and exhibit phytotoxicity symptoms such as yellowing of the leaves and burning, so it's wise to test first. Commercial oils are either highly refined petroleum-based or plant-based oils formulated with emulsifiers to blend with water for ease of application. Plant-based oils are less highly refined and are more likely to cause phytotoxicity. A very popular plant-based oil is neem oil. There are two types available: cold-pressed and clarified hydrophobic extract. Cold-pressed is simply the fruit and seed of the neem tree that is pressed to release the oil. It contains azadirachtin, a very powerful botanical insecticide. Clarified hydrophobic extract has had the azadirachtin removed, leaving a vegetable-based horticultural oil. Unlike soaps, oils are effective against exposed eggs. They are also effective against soft-bodied insects like aphids, whiteflies, mealybugs, thrips, leafhoppers, and spider mites. Neem oil is also used as a fungicide and is repellent to some insects and nematodes. Horticultural oils kill by obstructing the spiracles or breathing tubes and thus suffocate the insects. Cold-pressed neem oil may have additional insecticidal properties, causing disruption of the feeding and growth and molting cycles. Oils require direct contact and have little residual action. Neem cake is a byproduct of neem oil and azadirachtin production, and it's used as a fertilizer and nematode repellent. And I use it often when I'm planting tomatoes. I just toss a little bit in the hole at the time that I transplant them, and it seems to help. I don't have much of a nematode problem because I use resistant varieties most of the time. But if I plant a heirloom variety, then sometimes I'll use neem cake or neem granules in the hole as I transplant, and it seems to help deter nematodes. Biological insecticides like Bt and spinosad are produced from naturally occurring bacteria. Bt stands for Bacillus thuringiensis and is a bacteria found in soil. It reproduces by spores, and the spores produce a protein that, when ingested by the larval form of some insects, is toxic. The toxin damages the gut of the insects, which stop eating and die in 1 to 5 days. The protein must be ingested to be effective. There are several strains of Bt that are used to kill beetle larvae, mosquito larvae, and moth and butterfly larvae, which of course are caterpillars, in the most, and that is the most common strain that we see most often. Bt is fairly specific to the target species and has very low toxicity to mammals. The protein requires a very high gut pH from 9.0 to 10.5 to be activated. Since mammals have a very low gut pH, Bt has extremely low toxicity to mammals. Bt is often used proactively on vegetables along with insect barriers like row cover or shade cloth. Spinosad is another substance produced from bacteria. It is a combination of two chemicals, spinosyn A and spinosyn D. Spinosad kills insects by disrupting their nervous system and causing paralysis and death, typically in 1 or 2 days. It may be ingested or contact the target insect. It breaks down quickly in sunlight and even faster in water. Spinosad is minimally toxic to humans and pets and passes harmlessly through the body in 1 or 2 days. Spinosad is effective against Colorado potato beetles, cabbage loopers, armyworms, thrips, fruit flies, bagworms, tent caterpillars, pill bugs, and earwigs. I use spinosad proactively on pill bugs to prevent them from destroying tender seedlings. As a general rule, pill bugs are beneficial in consuming decaying organic material, but they seem to have a taste for tender seedlings. And once the plants mature, they're no longer a problem. So the goal is not to exterminate them, it's just to prevent them from destroying the seedlings for a few weeks. Usually 1 or 2 applications will get the job done. We've reached what I would consider the apex of the organic insecticide solutions, pyrethrin and azadirachtin. Pyrethrins are natural substances found in some flowers of the chrysanthemum family. Pyrethrin is a broad spectrum insecticide. That is, it's toxic to a large number of insects. Pyrethrin has been around since the 1950s and is the active ingredient in over 2,000 registered products. Pyrethrins excite the nervous system and quickly lead to paralysis and death. Pyrethrin is a contact insecticide and must be sprayed directly on the target insect. Once it's dry, it has little, if any, residual effect. Pyrethrins are minimally toxic to mammals and birds, but extremely toxic to fish, shrimp, and oysters. It is also highly toxic to bees when wet, but once dry, it's minimally toxic to bees. Avoid spraying open flowers and don't spray when bees are active. Azadirachtin is another botanical insecticide made from pressing the fruit and seed of the neem tree. The azadirachtin is removed from the resulting oil. Azadirachtin is an antiphedant and growth disruptor and also disrupts the reproductive functions. It is toxic to a very large number of insects, but is most effective on immature stages of most insects. It's most effective against growing insects such as caterpillars. Azadirachtin has some fungicidal and repellent properties as well. Both pyrethrin and azadirachtin are listed for hundreds of insects. They can be applied as sprays or soil drenches depending on the target species. Because of the wide range of toxicity, there is a potential for damage to non-target species, so caution is recommended. As with any pesticide, always read and follow the instructions carefully. Now let's take a look at organic herbicide solutions. Most of them are acids of some kind. The first is horticultural acetic acid. Household vinegar is about 5% acetic acid, and horticultural acetic acid is between 20 and 40%. And it's normally used full strength. Horticultural acetic acid may be available, but it's also used as a cleaning product and can be found in janitorial supplies of big box stores. It works best when applied in the heat of the day when plants are actively growing. Many of the commercial products contain a blend of caprylic acid and capric acid. They are available in ready-to-use concentrate or in concentrate. As with any pesticide, read and follow the instructions. In my experience, those products work best on broadleaf weeds. They will work on Bermuda grass, but it may take several applications to get the job done. Okay, we've arrived at the apex of the IPM pyramid, and this is chemical pesticide solutions. Zeta cypermethrin, some of these are hard to pronounce, so is a synthesized chemical similar to pyrethrin. So it's a pyrethroid insecticide. Pyrethroids are very common and active ingredients in today's insecticides. It kills insects that eat or come in contact with it. It affects the insect's central nervous system, and zeta cypermethrin replaced carbaryl as the active ingredient in products available to home gardeners. Carbaryl is still used in commercial and agricultural products. It's much more persistent in the environment than natural pyrethrins. ZC may take as long as 150 days to completely degrade. This persistence means it has residual action and will continue to be lethal for some time after the application. Cypermethrin has a low potential to move in the soil, so it's unlikely to contaminate groundwater. It's highly toxic to fish and aquatic insects, though. It has low toxicity to birds, and humans excrete cypermethrin quickly, so it's not likely to build up in the body. The amount and frequency of exposure to cypermethrin to humans and the health of the individual influences the effects on humans. It's very toxic to bees and a wide range of insects, so caution is advised. There are many products containing pyrethroids as an active ingredient. Cypermethrin is just one. There are perhaps dozens of pyrethroids. Organophosphates were developed to replace organochlorines such as DDT. Organophosphates require very careful handling. Some examples are malathion, diazinon, and chlorpyrifos. Their use has been restricted due to health concerns. Malathion is still available, and diazinon has been restricted but may still be available in some states. Chlorpyrifos has been severely restricted. Organophosphates disrupt nerve function in insects. They are broad-spectrum insecticides and kill a wide variety of insects. They are very toxic to bees and other beneficial insects. Malathion is only moderately persistent. having a half-life of 1 to 17 days. It does not appear to build up in the environment. Neonicotinoids are systemic insecticides that affect the nervous system of insects. Examples include imidacloprid. Hopefully you can see this and read this for yourself, but because these are really difficult to pronounce. The systemic properties preclude their use on vegetables, but are widely used on landscape and houseplants. Their use has come under widespread scrutiny because of their potential impacts on pollinators and other beneficial insects. For that reason, I do not recommend their use in an IPM program. Now let's take a look at chemical herbicides. Some are non-selective and kill a wide range of broadleaf weeds and grasses. An example of a non-selective herbicide would be glyphosate. 2,4-D is an example of a selective herbicide. It kills most broadleaf weeds, but not most grasses. I'm not even going to attempt to say this next one, but they kill grasses, but not broadleaf weeds. There are pre-emergent herbicides like trifluralin that control annual grasses and broadleaf weeds. The choice of chemical pesticides is so large it can be bewildering. But begin by identifying your target, either an insect, weed, fungi, or disease, and begin searching from there. Use the most target-specific product that you can. Some of these products are listed for hundreds of target species, and they kill almost anything they touch. So always read and follow the instructions. You can download instruction sheets for most products from the internet. They're much easier to read than the ones that are attached to the product. And by doing this, you can read the instructions without buying the product. That way you know that the product that you're buying is listed for the target species that you need to control. You can find out, you can also read the application instructions. So some herbicides must be mixed with a surfactant. So become a label reader. Look for active ingredients. Products often change the active ingredients. For example, 7 used to be a carbaryl product, but now products for home use are zeta cypermethrin, and carbaryl is reserved for the agricultural and commercial 7 products made by Bayer. So even products with the same name can have different active ingredients. So don't beat yourself up if you need to use one of these products. Just try to use it in the most responsible way possible. I've been battling Bermuda grass in the aisles around some of my raised beds that I've had to resort to using over-the-top grass killer. Its use is very limited and doesn't get in my vegetable garden, so I'm not going to lose any sleep over using it. IPM had its beginnings back in the 60s, and with the realization that we were doing serious damage to the environment in an effort to control pests. What began with the lofty notion to partner with nature to control pests has morphed into a nationally accepted practice that saves money and the environment. Our IPM takes a proactive, holistic approach to incorporating sound cultural practices in sanitation, physical and mechanical solutions, as well as biological options to work with nature to manage pests. Only as a last resort are organic and chemical pesticides called into action. Texas A&M and the state of Texas were leaders in IPM as far back as 1972, when IPM was used successfully to grow cotton, sorghum, and peanuts in Texas. Now, every state extension service that I've come across has an active IPM program. But IPM is an ideal approach for a home gardener. The smaller scale is easier to manage, and soil quality and fertility is easier to achieve. It's hard for me to overstate the importance of the first few proactive levels in the IPM pyramid. Having great soil and healthy plants makes so many problems go away. So, what could be better than growing clean, healthy food and helping the environment at the same time? Thank you so much for your time and attention. Here is some contact information, and if need be, then please contact me for questions. Thank you very much.